Class 12 Chemical Kinetics Most Important Questions with Answers. Q1. State a condition under which a bimolecular reaction is kinetically a first-order reaction. Answer. This is possible in case one of the reactants is taken in large excess so that its concentration changes very slightly in the reaction. The reaction is a pseudo-first-order reaction. For example, hydrolysis of an ester in an acidic medium. Q2. Write the rate equation for the reaction to A plus BC if the order of the reaction is 0. Answer. The rate equation for the reaction to A plus BC in the zero-order reaction is rate is equal to K, A, 0, B, 0 is equal to K3. How can you determine the rate law of the following reaction? 2NO plus O2NO. Answer. The rate law for the reaction can be determined experimentally. Firstly, the concentration of one of the reactants, let O2 is taken in large excess and the reaction rate is determined with respect to NO, G. Then the other reactant NO is taken in large excess and the reaction rate is determined with respect to O2. The rate law expression for the reaction may be expressed as rate is equal to K, NO, X, O2, Y, where X and Y are actual coefficients of the reaction. Q4. For which type of reactions, order and molecularity have the same value? Answer. Order and molecularity have the same value for elementary reactions that are taking place in a single step. Q5. In a reaction, if the concentration of reactant A is tripled, the rate of reaction becomes 27 times. What is the order of the reaction? Answer. For the reaction, rate, R, is equal to K, A, N, 1 according to the given date rate, 27 R is equal to K, 3 A, N, 2 divided equation, 2 by 1, 27 R, R is equal to K, 3 A, N, K, A, N 27 is equal to 3 N, N is equal to 3. The order of the reaction is 3. Q6. Derive an expression to calculate the time required for completion of a zero-order reaction. Answer. From the zero-order reaction we know A is equal to A, 0 kT for the completion, A is equal to 0, therefore T is equal to A, 0 kQ7. For a reaction A plus B products, the rate law is rate is equal to K, A, B, 3, 2. Can the reaction be an elementary reaction? Explain. Answer. In an elementary reaction, the number of atoms or ions which are colliding to react is known as molecularity. Had the reaction been of elementary nature, single-step reaction, the order of reaction with respect should have been 1 but it is 3/2 I fractional. This shows that the reaction is of complex nature and is not an elementary reaction. Q8. For a certain reaction, a large fraction of molecules has energy more than the threshold energy, yet the rate of reaction is very slow. Why? Answer. The reaction rate generally depends on two factors, orientation factor and energy factor. Apart from possessing energy equal to threshold energy, the reacting species must be properly oriented at the time of collision. In the reaction under observation, the orientation effect is not proper. Therefore, effective collisions are not much as expected. The reaction is therefore a slow reaction. Q9. For a zero-order reaction, will the molecularity be equal to 0? Explain. Answer. No, the molecularity for the reaction can neither be 0 nor fractional. Q10. For a general reaction AB, the plot of concentration of a versus time is given in Fig. Answer the following question on the basis of graph. A. What is the order of the reaction? B. What is the slope of the curve? C. What is the unit of the rate constant? Answer I. From the graph of the concentration of a verse to show the equation of zero-order reaction I dot E A is equal to A 0 kT. Here the slope is negative 2. The slope of the curve is K. 3. The unit of the rate constant is equal to mol L-1 S1. Q11. The reaction between H and O is highly feasible, yet allowing the gases to stand at room temperature in the same vessel does not lead to the formation of water. Explain. Answer. The reaction between H and O is highly feasible, yet allowing the gases to stand at room temperature in the same vessel does not lead to the formation of water because the activation energy for the reactants is very high at room temperature and it is not readily available. Q12. Why does the rate of a reaction increase with a rise in temperature? Answer. With rise in temperature, the energy possessed by the reacting species increases. As a result, more species are in a position to cross the activation barrier. Therefore, the reaction rate increases with a rise in temperature. Q13. Oxygen is available in plenty in air, yet fuels do not burn by themselves at room temperature. Explain. Answer. The activation energy for the combustion reactions of fuel is generally very high. This is not available at room temperature. The fuels as such are not in a position to burn or undergo combustion at room temperature. Q14. Why is the probability of reaction with molecularity higher than 3 very rare? Answer. Molecularity of a reaction is defined as the number of the reacting molecules species that are colliding simultaneously. As the number increases, the chances of their simultaneous collision decreases. This means that it is very little probable that more than 3 reacting molecules may collide simultaneously. In other words, the probability of reactions with molecularity more than 3 is very rare. Q15. Why does the rate of any reaction generally decrease during the course of the reaction? Answer. The rate of any reaction is proportional to the concentration of the reactants. With the progress of the reaction, the concentration decreases gradually and so does the rate of reaction. Q16. Thermodynamic feasibility of the reaction alone cannot decide the rate of the reaction. Explain with the help of one example. Answer. Many chemical reactions are thermodynamically feasible, which means that the enthalpy of reaction, delta RH, is negative. Still, they do not occur. Actually, the activation energy is another factor which influences the reaction velocity. In case the reacting molecules do not have sufficient activation energy, their collisions will go waste without resulting in products. Q17. Why in the redox titration of KMnO4 versus oxalic acid, we heat oxalic acid solution before starting the titration? Answer. The reaction is very slow at room temperature. By raising the temperature, the reaction rate increases. Normally in this reaction, KMnO4 acidified with dilute HSO4 reacts with oxalic acid at a temperature of about 50 degrees Celsius. Q18. Why can't the molecularity of any reaction be equal to 0? Answer. Molecularity of any reaction is given as the number of the reactant molecules or species that are colliding simultaneously in the elementary reaction. A minimum of one reactant is needed to initiate a chemical reaction. Therefore, the molecular mass of the reaction cannot be zero. Q19. Why is molecularity applicable only for elementary reactions and order is applicable for elementary as well as complex reactions? Answer. Elementary reactions proceed in a single step while complex reactions generally take place in many steps. In multiple step reactions, each step has its own molecularity and the molecularity of these steps are not added up. Therefore, complex reactions have no molecularity. On the other hand, in a complex reaction the order as determined for the slowest step, also called rate determining step, represents the order for the entire reaction. Hence, we may conclude that molecularity is applicable only to the single-step reactions whereas order applies to both elementary and complex reactions. Q20. Why we can not determine the order of a chemical reaction by taking a balanced chemical equation into consideration? Answer. The sum of the stoichiometric coefficients of the reacting species in a balanced chemical equation may or may not represent its order. This is possible only for elementary reactions which proceed in a single step. In multiple step reactions, the coefficients of the reacting species involved in the rate law determine the order of the reaction. For example, KClO3 plus 6FeSO4 plus 3H2SO4 KCl plus 3Fe2SO4 3 plus 3H2O. The sum of the stoichiometric coefficients in the reaction is 10. But the reaction has been found to be of second order. This means that it is a multi-step reaction, and in the slowest or the rate-determining step the sum of the coefficients of the reacting species involved is only 2.